exactly the same thing. Yeah? So, just to remind you, if I had 2/9 and I added 5/6, it is not 7/15. What is it? What do I need to do first?
Make the denominator.
Have a common denominator. What is it? 18. 18 will work. There's another way you could do it. You could just do 9 times 6 to get 54, yes? But then you will have more simplifying to do. If you're actually good with your times tables, then you can find the real lowest common multiple. Or you can remember from grade 10 when I taught you how to do it with products of prime. But it is indeed 18. What did I do to that to get to 18? So what must I do to that guy's numerator?
Multiply by 2.
What did I do to that guy? What do I do to that guy?
Multiply 3.
So I get 4 plus 15 to get 19/18. Yeah? Grade 3, grade 4, grade 5, depending on where you were. Kindergarten if you were from Brazil. Depending on where you were. Preschool if you were from Japan. Right? Part of, see Dick and Jane run and then add some fractions if you were from Japan. But we can all do this, yes? Okay. It is no different here, except it's more complicated, yes? So if something is more complicated, what should we do? We should simplify. So the first step, just like in multiplying and dividing, is simplify through what process? Simplify through factoring. Where do you factor? Every single spot you can. As much as you can. Everywhere. All right? Now this is where it's going to get weird. So, in this pink one over here, I don't have to do any factoring, do I? Mm-hmm. Right? So, the next step was find an LCD, lowest common denominator, right? Now, what's the easiest way to find the lowest common denominator between 9 and 6? What's the easiest way? Just multiply them together, yeah? Because we could have done this with 54, right? So if that's the easiest way to do this, what do you think you should do when it's complicated?
Make it simple.
Make it simple. Find an LCD by multiplying all denominators. But there's a trick. I'm going to write denoms because I'm out of space. Don't expand. What? Don't expand. We've already got it simple. When you expand it, it is no longer simple, is it? Mm-hmm. Don't expand. I'm going to highlight that in pink. Because in the 1980s, green and pink were a hot color combination to put together. Don't ask me why. It was a very hot color combination, green and pink. It was in the preppy handbook.
What's a preppy handbook?
Something that many of us in the 80s used to help us dress. Everybody cool? And finally, just like over here, once we had our common denominator, what did we have to do? We then had to adjust our numerators. Now, once all that is done, I can then add the expressions. Okay? It's really simple when you see it happening. Let's start with this nice, easy first one. Is there any factoring to be done? Absolutely not. Okay. Is there a lowest common denominator?
Yeah.
What is it?
B.
B. So everything is going to be over B. So I have 2a minus a minus 1. Why did I put brackets around a minus 1? Because there's no brackets there, so why would I put those brackets there? Right. Because 2a, I am subtracting that whole binomial, yes? Mm-hmm. So I have to subtract a minus 1, which means a negative in front is technically negative 1, yes? Yeah. And that negative 1 technically distributes, yes? Yeah. So what I really have is 2a minus a plus 1 over b. A bunch of you are going to make that mistake a bunch of times. So what's the answer? Because now we found our LCD, we've adjusted our numerators, now we just got to add them. What goes together?
A and A.
A and A. What's 2a? Take away an A. A plus 1 over b. Are there restrictions?
No. I mean, B cannot be 0.
B cannot be 0, yeah? All right. Next one. Do we have a common denominator?
Yeah.
What is it?
X plus 4.
X plus 4. So it's 2x plus 8, correct? Mm-hmm. Okay. What should I do now? Factor, factor, factor. Where do I factor? What comes out? 2. X plus 4 over x plus 4. Multiplied, what do I do?
Restriction.
Any restrictions?
X minus
X can't equal negative 4, and then what? Simplify, simplify, simplify. Cancel, cancel. What's the answer? 2. Good?
Good.
All right. Last one. You guys do it. Go. Everyone is good, yes? As long as the equations are the same, everyone's good, right? Everybody sees what we did here? Added them up, simplified because it factors and canceled. Everyone's cool?
Yes.
Going once, going twice, going thrice. What's different about number 4?
The denominator is not same.
I do not have the same denominator, do I? And one of those terms is missing a denominator. So what should I do?
Make it.
I should make it what? I should make it 1. Now, what is my common denominator? How do I find it? Multiply all the denominators together, right? Mm-hmm. So, my LCD, lowest common denominator, equals xy times x times 1. What is it?
X third.
X.
Because it's x squared.
Oh, thank you. X squared.
X third.
X
squared,
cubed.
Y.
Y. Does everyone agree? Yeah? Everyone's happy? Okay. So what now? Have I got my common denominator? What's step 2?
Multiply the same.
Multiply all my denominators together and don't expand, yeah? Mm-hmm. Okay. So, what's going to happen? All right, let's talk. Let's rewrite 2x over xy plus 4 over x squared minus 3 over 1, yeah? What's my common denominator? X cubed y, right? Which means this term has to multiply by x cubed y, correct?
Correct.
What about this term? I'm going to change color there.
XY.
X cubed y, and x cubed y, correct? Okay. What do you see on the top and bottom here?
XY.
What's going to happen? I got 3 x's, I got 1 y. What's going to happen?
So
What's going to happen to one of those x's? I got an x on the bottom, I got x cubed on the top. This is not complicated, ladies and gentlemen. It's going to be x squared. What about y and y? Gone. So that is going to become x squared, because that takes care of that, and that's going to be gone. What's left? X squared and an x there. So what's that?
X squared cubed.
2x cubed. What's going to happen here?
The same thing. So
Not quite the same thing.
X will be there,
1x will stay.
and Y will stay.
So I'm going to have xy. So that is going to be plus 4xy, correct? Okay, what's going to happen here?
And there's no
Nothing, so it's minus
3x.
3x cubed y. All over what?
All over x cubed y.
X cubed y. Now what?
Simplify. I mean, factor.
Is it all over x cubed y?
Yeah.
Okay,
So factor.
so simplify. Where now? Okay, what can come out up there? X is coming out. Agreed? What stays in? 2x squared plus 4y 3x squared y. All over x cubed y. Is there any more canceling to do? Where? That x can go, yes? So, gone. What happens to one of those x's? Gone. So what's my final answer?
X squared.
2x squared plus 4y minus 3x squared y over what? X squared y. Is everybody cool? I just ran through everything I did, right? Now, where most of you have a problem is over here. Right? But remember, this is what is happening, and I'll draw it in a different color completely. I had 2x over xy, and my common denominator was x cubed y, right? So when I do that, multiply by 2, right? They both multiply by x cubed y. So I'm going to multiply this by x cubed y, which means that's technically over 1, yeah? That's why this is working. That's why I'm just canceling over here. Everybody cool? All right, let's try the next one. It's a little harder. What are you going to do with 5? What don't you like? What bothers you? Same first step that we've made all along. What should I do?
Make the denominator same.
No.
Factor.
Factor. How do I factor the green one? What's that? Does it factor? No, why not? It's not 2 squares, is it? So can I change that guy? No. He stays as y squared minus 20. Can I factor the blue guy? What is it? minus 2. Correct? Plus y plus 2 over y minus 2 over y plus 2. Now what do I need? Have I factored everywhere I can? Okay, so now I got to get my denominators common, right? Now you want to multiply those denominators together, right? Do you need to? You've already got a y2 there, right? Y plus 2
How about
multiplied by y minus 2, correct? Well, over here I've already got y plus 2, don't I? So what's the only thing missing from over here?
y minus 2?
I need to multiply a y minus 2 over here, don't I? If I had a y minus 2 here, I'd have the same denominator, correct? So if I multiplied the bottom by y minus 2, what do I have to multiply the top by?
Y minus 2.
Y minus 2. Now, let's adjust. Do we have a new common denominator? It is y plus 2, y minus 2, correct? This guy already had that, didn't he? So do I change his numerator? No. Just like if I'm adding fourths and halves. I don't change the fourth, I only change the halves. Because the fourth had the right denominator, didn't it? So that's y squared minus 20 plus, now what do I got to do over here?
Y minus 2, y minus
Y squared minus what? 4y plus 4. Now what should I do? Simplify. Same way we simplified in grade 9, right? So, what's y squared plus y squared? 2y squared. What's no y's plus negative 4y's is negative 4y. What's negative 20 plus 4?
So negative 16.
Negative 16. All that over y plus 2, y minus 2. Now, what is something you could do right now? You could do your restrictions because you have a denominator. So what would that be?
Then y can't equal plus or minus 2.
Plus or minus 2. There's our restriction. It's out of the way. What is something else we could do right now? Remembering that we have 11 years of math to call on right now.
Factor it?
We could factor. What could come out of there?
2.
2. Oops, I want to keep working green. Y squared minus 2y minus 8 over y plus 2, y minus 2. Is there anything more we could do with that?
Yep.
What?
More factor.
Factor again. 2y plus 2, y minus 4, right? Over y plus 2, y minus 2. What can I do with that?
Delete.
Cancel what?
Cancel y plus 2.
Y plus 2 and y plus 2. Leave me with a final answer of
2y. 4.
lot of work, lot of steps that you already know how to do, right? The only new thing is, wait a minute, nothing. What new math have you been taught in this entire unit? Nothing. You already know how to do common denominators. You already know how to multiply fractions. You already know how to factor. You already know how to cancel. Is there anything new yet? No. So the only thing we need to do is put stuff together that we already know, correct? All right, let's look at the next one. Number 7 is a butt kicker. We'll get to that in a minute. What am I going to do with 6?
Factor it.
Factor, factor, factor. Everywhere I can. What's the yellow guy factor to? Should have been yellow. What does the yellow guy factor to?
X plus 3 and x minus 2.
X plus 3, x minus 2. Yeah? Minus x minus 2 over, what's the blue guy factor to?
X plus 3 and x plus 1.
X plus 3 and x plus 1. Right? So, what then is my new common denominator? What should I do with them? Read in the steps at the very beginning. I should multiply them all together, yeah? Mm-hmm. Because, not like this one, there's nothing common to both, is there? Yeah. Right? Well, there is. I know I need an x plus 3. But then what else do I need?
X minus 2.
An x minus 2 and x plus 1.
1.
What does that guy have?
X plus 3 and
He's got the 3 and the 2. What's he missing?
the 1.
So what does this one have to multiply by?
X plus 1.
X plus 1. What does this guy have?
X plus 3 and x plus 1.
The 3 and the 1. What's he missing?
2.
So this guy needs x minus 2. What should I do here and here? Multiply. What's x minus 1 times x plus 1? X squared minus 1. Minus, what's this one?
X squared
X squared
minus 4x
minus 4x
plus 4.
plus 4. What should I do there? If I were in grade 9 and not worrying about the bottom, what would I do there? Put it together by collecting my like terms. What's x squared minus x squared? Gone. What's negative 1 minus minus 4?
3x, 4, positive 4x.
I can't put negative 1 with 4x, right? So it's positive 4x. And what's negative 1 minus positive 4?
5.
What kind of 5?
Negative 5.
Negative 5. That and that are all the same thing. Is everybody good to there?
Yeah.
Okay. And what's my denominator? I've already got it. X plus 3, x minus 2, x plus 1. Does that factor?
No.
So can I do any canceling?
No.
So am I done?
Yes, but you need to do this.
What are my restrictions?
Negative 3, positive 2, negative 1.
Nothing new. Right? What's the only way I can make it difficult? By doing it like number 7. Look at number 7. Why is it scary?
There's a fraction and a fraction.
There's a fraction and a fraction, yes? But if I rewrite this as 1 plus 1x divided by x minus 1 over x, is it now easier to see? Because what would I do if that were a fraction? What would I do when it comes after a divide?
Flip it.
Flip it. So we know what to do, don't we? So all we need to do is simplify what I've got here. I'm going to simplify this yellow one first. Any factoring to be done?
No.
No. So what's my common denominator?
X.
X. This guy already has x, doesn't he? So what do I got to multiply this guy by?
X.
X. What's x times 1?
X.
X plus 1 over x. Does everybody see what we did? You have to stop me if you don't. Because that's actually something that's really easy to get. Everybody cool? Okay. What do you want to do here, Derek? What do I need to do to make this work? I need a common denominator of what? X. This guy already has x. So if I was adding 1/2 plus 1/4, my common denominator is 4, correct? So do I change this guy? No. So do I change that guy? No. So it's plus 1. Did I change that guy? What did I have to multiply that guy by to get to 4? Times 2. So I got to multiply this guy by what? Times 2. What did I have to multiply this guy by? 1 to get him to x. I had to multiply him by x. So what do I got to multiply his buddy by? X. What's x times 1? 1x plus 1 because I didn't have to change him. Cool? All right. Divided by, what's this guy? What's the common denominator? X. Did this guy have x?
Yeah.
So what I got to multiply this guy by?
X.
X. So it's x squared minus 1, correct? Now, what do I do when I see divided by a fraction? Flip it. So it's x plus 1 over x times x over x squared minus 1, yeah? Now, what? Simplify everywhere I can. X plus 1 over x times x over x plus 1, x minus 1, correct? Now what? What should I check for now? Restrictions, because it's totally cleaned up, right? I got to check where? Everything on the right and any other denominators. So x cannot be 0, because that can't be 0 and that can't be 0. And x can't be plus or minus 1, because that can't be 0. Then I just do what? Cancel, cancel, cancel. What do I do with these x's? Gone. One on the top, one on the bottom. What do I do with x plus 1 and x plus 1? Gone. What's left?
X minus
1 over x minus 1. I can't remember there's a 1 there. I can't forget there's a 1 there. Now, again, looks hideous. Is it?
Yes.
Don't be that way, Ayaka.
It's really good.
Please notice that as soon as I break it down to this, for example, this becomes easy. I remind you all, every piece of math you need to solve the hardest problem in this unit is already in your head. So look at one part of it and fix that. Just like if you were about to run a marathon. You don't worry about the last 5 steps after you've run 42 kilometers, do you? You worry about the first 42,000 steps. And you don't even worry about that. You worry about the very next step you have to take. Because every step gets you closer to the end. Okay? Everybody good? Feeling confident? A little?
A little.
All right. You got 27 minutes. Page 132 and 133 is your homework. 134 is going to be your next assignment, which we are going to do in class tomorrow after we write a quiz. You're going to come in tomorrow. We're going to go over 132 and 133. You're going to write a quiz. We're going to mark it. After you've seen it marked and we've gone over it, I'm going to give you an assignment. That assignment will be due depending on how tomorrow goes. Possibly at the end of tomorrow's class. Oh no, because tomorrow's an X block day.
Yeah.
So it's a short day. So it'll be due at the beginning of Friday's class. If you need to sign up somewhere for X block, I am wide open. Not one person signed up. Tomorrow is the 15th. Yeah, yeah?
Yeah.
Yeah, yeah. Go diddly-o.